Okay, hello everyone. Welcome once again. All right, so we are continuing with 7.1. That is last sample estimation of the population mean. All right, so we want to get an interval estimate that will estimate our population mean. But in this case, you are just focusing on large sample. If you are focusing on large sample, it implies that we are dealing with the normal distribution. So we are going to use Z alpha over 2. The Z alpha over 2 was what we did in our introduction. You know that in creating an interval, always we want, if you are talking about the population mean, then we use this point estimate S bar to help us create the interval plus some kind of plus or minus some kind of margin of error E. So what we do is that we write S bar, which is the point estimate plus or minus E. Or we can write this S minus E and S bar minus E, S bar plus what E. Okay. So this help us create the interval. That's why this is the lower value, this is the upper value. So what is the E? This is the E that we want to find now. What entails in the E? All right. So from the formulas in this, realize that the E part of it is our Z alpha over 2 sigma all over square root of n. This part that we see is the standard deviation of our S bar. Okay, so this tells us how many standard deviations or how many standard deviations you have to go in order to capture our population mean within the interval. That is why it's the margin of error. Okay. All right, so that is why we first got to know how to find this. So in this, you are going to also get to know how to use the calculator to get the interval at once. Even if you don't have a calculator and you want to work it out manually, then you know how to find it. Z alpha using the calculator and also from the table. Then multiply by the standard deviation of S bar, which is sigma over square root of what? N. N is your sample size. And in this case, you are considering N greater or equal to what? 30. But if sigma is not known, then we use the point estimate S, which is the sample standard deviation to estimate it. So in place of sigma, we use what? S. So now our E will be equal to sigma alpha over 2 S all over square root of N. Are you okay? That is that. But if sigma is known, you just maintain it. That is for the last sample. It's very simple as that. So then let's begin. And so this is a calculator way of doing it. You click on the stats. You push your arrow to the test, then you choose the interval. Then you input what you need to input there. You get your interval. All right. So this is your E. So in case I tell you to find the margin of error only, then it is the Z alpha over 2 times the sigma over square root of N or S over square root of N. What you have to note importantly is that if your N is greater or equal to 30, if it's large, then you use the Z alpha over 2 always. Okay. If the sigma is not known, then that's where you represent it by S. But we have another case when the N is less than 30. Then what you have to consider is that is your sigma known? If the sigma is known, still use your Z alpha over 30. But if the sigma is not known, then you have to use what? Your T alpha over 2. So since we know that if the sigma is not known, we always use S. If you want to calculate your E, then now your E will be equal to T alpha over 2 with something we call the degrees of freedom. We're going to talk about that. This is not something and use S over square root of N. All right, so we're going to consider this case in section 2. So let's get to solve some examples. All right. So we have a sample size. If I do one, you can do the others. If you have a sample size, that is our N, which is 49. So it's large. If it's large, you are going to use the alpha over 2. Now the thing to consider now is that are we using sigma or are we using S? So realize that we've been given the population standard. So the population is the sigma. Okay, so we've been given the sigma. If it is sample, the right sample standard deviation. So now we have sigma, which is what? 14. We have to construct a 95%. So this is our level of confidence, which is our C. Okay, or the for the population parameter mu. Then we interpret our results. Okay, so what you do is that there are information you have to note down if you have to work it manually. So in creating the confidence interval using the formula, we write S bar plus or minus Z alpha over 2. Now we know the sigma and the square root of N. This is 49. This is what? 14. So what is left is to find this. Then you use the inverse norm to find that, okay? But as I told you earlier on, given some level of confidence, you can get a Z alpha always instantly. So when you have confidence level to be 95, then the Z alpha is 1.96 rounded to what? 2 decimal places. So you don't know. So now the S bar has been given. That is the sample mean. So we realize the sample mean is 35. So in view of this, in everything, if we want to put everything together, then this is how we calculate our confidence interval or the interval estimate. So we're going to have it here. That is 35. Let me work it out here. So with this question, we have 35 plus or minus 1.96. Then you multiply it by 14 over square root of 49. Okay, so if you do this, you do plus. So you first do 35, maybe minus 1.96 times, this is times 14 over square root of 49. So this will give you the lower value. Then you do 35 plus 1.96 times 14 over what? Square root of 49. So if you are doing it manually, this is what you do. So you do this part, then you do that part. This will give you the lower, and this will give you that part. The whole of this is what I've split it like that. Okay, that is that. So that is how. But if you want to use your calculator, then let's go to the calculator way by the formula. So you have to use this approach. You have to use, so you click on stats, you go to tests, then you click on the Z interval. So let's see if you're going to get the same answer as this would have given us. So let's check on the calculator one. Okay, so we click on the stats. So this is stats. Then we choose tests. Then we scroll down to Z interval. So the Z interval is a 7. Click on it. Okay, so it tells us the sigma. The sigma is 14, right? What is S bar? S bar is 35. What is the sample size given? That is 49. And the level, C level, that is for you, we're giving 0.95. That's 95 is 0.95. Are you okay? So you supply the information in. So sigma is 14, S bar 35, N is 49. Then we are good to go. So that is the interval that you see, 31.08 and 38. So this gives you the interval that we want. I hope you're okay. All right, so that is what we did. This is our normal calculation, and the calculator gave us this value too, so which is the same. We want to use the calculator. Okay. All right, so we do the same thing. So always the things to note are your S bar, N, and sigma. The sigma is the population. If sample is given, please use the S, but it's going to give you the same thing. If N is large, it doesn't matter. Okay. So I think that is that. So we apply the same analogy to all of them. So in 36, in the 36 one, so this is our N is 36 greater than 30. We have 23 was found to be the mean. So the mean is 23 and the standard deviation was 6 point. Okay, so this, we made a selection. Okay, so this is an S given, that is 6.7. So you have to find the 96. So this is our level of confidence. So we use our calculator. We input that in the calculator and you're going to get our answer. So this is the calculator way of doing it, and you should get your final answer like that. So how do we interpret this? The interpretation is that we are 95%. So we have to construct a 95% confidence interval, right? So this implies that we are 95 confident that the population mean will be between what, 31.08 and 38.9. Now in today's the interpretation. So interpret it based on the confidence level given and the interval. So we are 95% confident. So if we are giving 90% confidence interval, then we are 90% confident that, what are we talking about? That the population mean or population proportion will be within what? Then you bring your interval, then you are good to go. There's also another way, but you can use this. There is a 95 chance of covering the population mean by our interval. Okay, that's it. So the interpretation is very simple. So always when you're asked to interpret, this is what you have to write. This is what you have to write. So all these are interpretations. Very simple to come with. Okay. So the same analogy applies to us. So now we go to the section 2 of it. Section 2.